So let me record that. Okay, right. So when we talk about audio production techniques, so even without the knowledge, so people can produce music, right? From prehistoric time, so human or our ancestors, prehistoric men, so they produce music, right? Like it is based on sound, and then they understood, right, the things. They use sound to communicate and for entertainment and many other aspects. But they didn't have that knowledge, what are the things behind this, right? So in that case, actually, like in universities or in similar institutes, so what we are doing is we want to get a systematic understanding and knowledge. So for example, like in early stages, like the concepts, the early concepts of music has been introduced by mostly mathematicians. So for example, Pythagoras. Pythagoras also, you have heard of Pythagoras. I mean, any student identify that name, like Pythagoras. So there are Pythagoras theorem, and then many other concepts have been introduced by him. He's a mathematician. In music, like he has, he's the one person. I mean, he could be the earliest person who provided some systematic knowledge or systematic concepts on music, right? So music, mathematics, physics, these are closely connected, right? So today, actually, let me share the screen and then let's continue. Yeah, so the last week, I wanted to introduce what is sound, and we talked about sound waves. So in when we talk about sound, there are two aspects, physical aspects or psychological aspects. Physical and then physiological aspects, and then psychological aspects. Even we don't, we are not there to hear or a sound, but still that physical aspects would be available. So however, to complete the circle, right? Complete the circle, psychological aspect should be there. We should hear that. Without hearing, I mean, the sound does not have any purpose, meaning, or whatsoever, right? So it is physical and psychological, right? Then we talked about physical aspects of sound, and then so there are several terms: sound, audio, acoustics. Sound is basically we call generally we call sound, and then we call audio when it comes to electrical energy or electrical signal or digital signals. It could be analog or digital, however, electrical, right? So then acoustics means like non-electrical. You could say non-electric. Audio acoustics, it could be two sides, right? So that's so we talked about that, and then in this module, so from today, so we are going to talk about some concepts of music and all, and then the rest of these slides, and then from next week we are dealing with audio, mainly audio, right? So we are going to do audio production, right? Not just sound production, right? So sound has, I mean, anyone can produce a sound, but audio production, so we have to learn a lot of technical stuff behind that. Of course, so there's some creative side to audio production. So, however, there are a lot of technical aspects behind that. Okay, when you are using these terms, just know what they mean, right? So sometimes we use them interchangeably, but so they are actually. However, it is like you have to know what they actually mean, right? Okay, so sound. When we talk about physical aspects, so there are two things: a sound source. There should be a sound source that that is any object that can vibrate. Vibrate when object එකක් තියෙන්න ඕනේ. ඕනෑම object. So now I am vibrating my vocal folds, right, to generate these sounds, right? So likewise, so there are a lot of objects that vibrates and generate sounds around us. So there should be a mass, and the object should be elastic. Elasticity should be there, right? So that's how those vibrations can be generated. That's how an object can vibrate. Okay, so then sound transmitters. So after generating sound should be transmitted through a medium, right? It's a medium with molecules. So those molecules are, so based on the sound source, the vibrations of sound source, the medium, molecules of the medium are vibrating, right? So that's the medium would be air, water, or any other solid wire, strings, whatever, right? So then when sources are sound source the object is vibrating, sound waves are generated. So sound is a result of vibrations of air molecules. Basically, in most of the cases, it is air molecules, but it doesn't have to be always air molecules. It could be any medium, right? Caused by motion of an object. Sound waves are longitudinal waves. The direction that the energy or the sound wave is transmitted, the molecules are vibrating parallel to that. Right? Molecules are vibrating in the same way, right? Parallel to the other sound wave is, or the wave is transmitted. So in this case, so we can identify rarefactions and compressions. Some areas are compressed with molecules, and then suddenly they become rarefaction after a move, right? So now this is a compression. So after maybe few microseconds, this would be a rarefaction, right? These molecules would be moved this way and the other way, right? Then rarefaction would be generated. So that's how sound is sound is transmitted through this medium, or in this case it would be air. Movements of the air molecules are in this way the direction of travel. So this is where sound is traveling. Right, so we talked about properties of sound, wavelength, speed, and then maybe frequency. I don't remember exactly where we stopped, but anyway, so let's go with generally I will give the summary in the general, right? So the wavelength is the minimum distance between similar points in the sound wave. So in this case, like actually in the previous case here, right? The rarefaction from here to the next rarefaction. Or compression from this compression here to here, right? The length between these points. මෙතන ඉඳන් ඒ කියන්නේ මේ අර ඔක්කොම එකට මොලිකියුල්ස් එකට ගොලි වෙච්ච compression point එකක ඉඳන් ඊළඟ compression point එකට තියෙන දුර wavelength. See, this is the wavelength. So if we represent those waves like this, so this is, so we have peaks, right? Peaks, or sometimes we call crest, and then troughs. Peaks or troughs, right? So we have peaks, between peaks or troughs, or it could be any other points, like for example, right, this would be again this would be the length of wavelength, right? and we can get the wavelength from here to here again. That's the wavelength again, the same length. It could be length between these two. Again, it is the wavelength, right? Adjacent, similar points. In this case, short wavelength, or we can have long wavelength. And then speed, right? Speed of the sound. Right? Speed of the sound is how much distant a sound wave travels per unit time. 1 second, how long the sound wave travels. That's basically the speed approximately. So it is 344 meters. So that means it per 1 second, right? In air at this temperature, 20. It could be different based on the temperature of the medium. Right? Then the frequency. The frequency is the total number of waves produced in 1 second. Right? So how many? So if I take, right? So this is, consider this as just one wave, right? One wavelength. So how many wavelengths are generated for in 1 second? Right? Suppose how many lengths are here? 1, 2, 3, 4, 5. Suppose in 1 second, 5 wavelengths are generated, right? So if we take the in the air, so then, right, like so. Likewise, so we have rarefactions and then compressions, right? So this is just one. So then two, 3, 4, 5, right? So in this case, 5 waves. So if we take this as just one wave, so 5 would be generated, or 5 wavelengths would be generated in 1 second. So we call it 5 hertz. 5 hertz. So hertz means the number of wavelengths per second, per unit time, or for 1 second. කියන්නේ මේ කී පාරක් මේක මේ wavelength කීයක් generate වෙනවද තප්පරයකට. එතකොට දැන් අපේ මොකක් හරි sound generate කරන source එක වේගෙන් vibrate වුණොත් frequency එක වැඩි sound wave එක generate කරනවා. If the object or the sound source which vibrates, if it vibrates fast, so then the frequency of the generated sound wave would be high, right? If it vibrates slow, right? meter එහාට මෙහාට යනවා නම් ඒතරේ generate වෙන sound wave එකේ frequency එක අඩු, right? Slow frequency, right? So that's the frequency, right? So in this case, this is low frequency, high frequency than this one. So measures in hertz, right? Measures in hertz. And it, so frequency is related to pitch. Right? So pitch is, so we are going to discuss in detail later. So pitch is pitch is how we perceive, right? Or how we identify the different frequencies, different frequency levels, right? So if it is high frequency, right? So we have a high frequency sound wave, right? So when we listen to that, right? So this person would identify, it is a high pitch sound. සමහරලාට අපි අර කියන්නේ මේ චර කෑ ගහන්න එපා කන රිදෙනවා කියලා වගේ කියන්නේ. ඒ කියන්නේ frequency එක වැඩි. ඒතර අපිට ඒක තේරෙනවා. So we can identify that. We can understand. frequency එක වැඩි වෙද්දී අපිට කනට අමාරු. හරි. So pitch is how we identify the frequency. The frequency is the physical pitch. So let's frequency is physical. Pitch psychological. This is psychological. So in that case, pitch could be little bit subjective, right? It could be the way I identify the pitch would be slightly different from other people, right? So it is based on my ear, right? So we are going to talk about that how we identify different frequencies so later. But this is subjective. Pitch is subjective. But we have defined some standards. So based on that, when we work in music, so we use those standards, right? But සමහර කට්ටියට සමහර දැන් සමහරලාට දැන් සින්දුවක් කියද්දී දැන් ඒ සින්දුවේ තියෙන notes හරියටම කියන්නේ සින්දුවේ දැන් මේ තියෙන මේ the notes ගැන අපි කතා කරනවා right notes හරියටම ඒ කියන්නේ අපි pitch එක හරියටම ආවද නැද්ද කියලා අඳුර ගන්න පුළුවන් right ඒ සමහර කට්ටියට ඒක එච්චර බෑ හරි ඒතර අපි සමහරලාට කියන්නේ හොඳ ear එකක් තියෙනවා කියන්නේ දැන් මේ music කරන්න හොඳ ear එකක් තියෙන්න ඕනේ කියලා මේ එමුනේ අකලංක
Yes.
Oh, so how do you identify the pitch and frequency? So, like, do you have anything to add?
No, I'm agree with you.
So, again, then me pitch එක මම කිව්වේ අර මේ subjective කියලා. ඒකට ඔය agree වෙනවද?
Yeah, because when it's come with according to knowledge of this, when someone has a knowledge of music, maybe the pitch will be he's looking at the pitch from musical view.
Yes. Yeah. So we can train, right? We can train our ear, but some people so they I mean naturally they are more sensitive to different pitch differences, right? So you may be one such person. So they can become like they can be good in music. ඒතර කියන්නේ දැන් සමහර කට්ටිය ඉන්නවා මේ ඒ කට්ටිය කියන්නේ pitch එක හොඳට ඒ කියන්නේ ඒ කට්ටිය හොඳට මේ sensitive pitch එකද හැබැයි ඒ කට්ටියට ඒ කියන්නේ මේ ඒ කට්ටිය musicians ලා නෙවෙයි දැන් එහෙම කට්ටියක් තියෙනවා ඒ කියන්නේ ඒ කට්ටිය මේ සමහරලාට මේ pitch එකට ගොඩක් sensitive හැබැයි මේ ඒ කට්ටිය මේ ඒ කියන්නේ දැන් උදාහරණයක් විදියට මේ සින්දු කියන්න බෑ ඒක දැන් මොලේ තියෙනවා හැබැයි මොලෙන් ඒක මේ process කරනවා හැබැයි මේ අර සින්දු කියන්න එද්දි ඒ කට්ටියගේ අර මේ මොකක් හරි හේතුවක් හින්දා සමහරලාට මේ එක්කෝ එක මේ දැන් අර vocal folds එක අර ඒ සිස්ටම් එකේදී ඒක කියන්නේ ජෙනරේට් වෙද්දි සමහරලාට එහෙම වෙන්නේ නැති වෙලා තියෙනවා. මේ දැන් අපි සමහරලාට දැකලා තියෙනවා එහෙම කට්ටිය මේ ඉන්නවා කියන්නේ මියුසික් නොලෙජ් එක සෑහෙන්න තියෙනවා. හැබැයි මේ සින්දු කියන්න බෑ. මේ සමහර මේ එහෙම කට්ටිය ඉන්නවනේ නේද? ඒ දෙක දෙකක් ඈ. ඒ කියන්නේ මේ සින්දු කියන්න පුළුවන් කියන එක නෙමෙයි මම කියන්නේ. මේ පිච් එකට sensitive. Right, so frequency and pitch, right? So these are the same thing but two perspectives. Okay, right. So frequency we measure in hertz. Right? So usually like the human or any species can so there's a limit that the frequency that they can hear, right? For example, like human, so their ear can identify from 20 hertz to 20,000. So these are maximum level or general level, right? as I told you last week, it is if you are very sensitive, you can have this level, or sometimes you can go beyond that. But basically, most of the cases, our levels are in between these, right? Could be different. So, however, general sounds that we are hearing, for example, the music that we hear, or the speaking someone. So those are kind of so there's a more limitations there, right? Like it's yeah, right. So general conversation, and then like music would be a little bit, it goes beyond that, right? But somehow our hearing is limited to this range. Generally, we 20 hertz to 20 kilohertz. This is kilohertz, 20,000 hertz, right? But like other animals like dogs, so they have a higher range. They are sensitive to higher range, so they can hear the sounds that we cannot hear, right? So that's why dogs are always like they seem to be listening to something always, right? So sometimes dog, they can identify their master's footsteps from the distance that we cannot even imagine, right? So like so there are differences of hearing in a different species, right? So then amplitude. So this is another aspect or property of sound, amplitude. The amplitude of sound wave is the measure of height of the wave, right? Now we talked about frequency, right? So the frequency, so this is high frequency, this is low frequency. And if we take the same frequency, if sound, the height of the sound wave, it is not very, very beautiful one, but I think you get the idea here, right? Right. Same frequency here. But the height is more than this. frequency එක එකම වෙන්න පුළුවන්. හැබැයි amplitude එක වෙනස් වෙනවා. So the amplitude is different in these. Frequencies are the same. ඒ කියන්නේ තප්පරයට එකම මේ අර කම්පන ගාන සමානයි. يعني කම්පණය වෙන ප්‍රමාණය සමානයි. හැබැයි මේ ඒක වැඩිපුර එහාට මෙහාට කම්පන. You take sound waves තප්පරයකට මේ දැන් molecules මෙන්න මේ level එකට ගියා කියලා හිතමු. මේ පැත්තට යනවා මෙතෙන්ට යනවා. මේක තමයි limit. This is the limit of the one molecule is like vibrating like this, right? Like this. Right? In another case, it would be vibrated more than that, like this. It is called the amplitude. The amplitude of sound wave is the measure of the height of the wave, how large the oscillations are. It is based on the amount of maximum displacement of vibrating particle. Maximum displacement from the neutral position. And this is related to loudness. Right? Again, so we can identify amplitude. And loudness. Right? So this is physical. This is psychological. Right? It's the same thing. So loudness means how we identify the amplitude. So physically amplitude is there. So based on that, loudness can be perceived. It's a perception of the amplitude. Loudness is the perception of the amplitude. It is related to loudness. Okay. So loudness, there's another slide. Talk about that. Right. So sound pressure level. Sound pressure level or acoustic pressure level is the logarithmic measure of the effective pressure of a sound relative to a reference value. Right? So in this case, so we can identify several things, right? Sound pressure level, right? Sound pressure level. Or sound intensity level. Intensity. Sometimes we call sound power level. So sound intensity level. So usually sound intensity means power carried by a sound wave per unit area, right? Unit area. කියන්නේ වර්ග මීටරයට කොච්චර power එකක් sound wave එකකින් අරන් යනවද කියලා. Right? So usually watt, right? But sometimes like it could be mix up, right? Like the power level, pressure level. මේවා සමහරට පොඩක් mix up වෙන්න පුළුවන්. ඒ කියන්නේ මේ එකකට එකක් මාරු වෙලා එහෙම පාවිච්චි කරන වෙලාවල් තියෙනවා. Right? So however, so this is sound power. Sound power. The power of the sound. So when I generate my this voice, right? This power I generate. කියන්නේ sound wave එකක් generate කරනවා කියන්නේ මේ power එකක් generate කරනවා. So we are generating a power. So that is a constant. Right? කියන්නේ ඒක generate කරාට පස්සේ ඒකේ power එක එකයි. ඒ power එක මේ විහිදලා යනවා. Right? Like it is transmitted throughout the air or the medium, and then the power level then intensity level means if we take so if I generate the sound in this imagine this is a sphere, right? Sphere, right? ගෝලයක් කියලා හිතන්න. If we take one square meter, right? So this is the sound source. Sound source is generating sound. Then this power is transmitted, right? Like this throughout the air. And then if I take just one, if we take one point from a given distance, right? One area per area, right? The unit area. It has a power, right? Power. මේ වෙලාවේ දැන් මෙතනින් මෙහෙම power එක ඇවිල්ලා මෙන්න මේ අපි ගත්තොත් එහෙනම් 1 මීටර එක එයා generate කරන power එක මේ මෙතනදී. අන්න ඒකට තමයි අපි කියන්නේ intensity level. Right? Usually total acoustic energy created by the sound source is a constant. It is not changing, but with the distance, the power intensity would be different. කියන්නේ මේකෙන් එකම කියන්නේ generate කරන power එක එකයි. හැබැයි ඒක මේ spread වෙද්දී when it's spreading the intensity levels would be different in different places. So in this room people can hear my voice, right? It has power to vibrate their eardrum when they are in this room. But when they are outside this house, or when they are 500 meters away from where I am now, so then they don't hear that because the intensity level would be 0 when I mean, this power or this the sound that I'm generating, the power of or the energy of that sound would be vanishing when it go along the way, right? කියන්නේ දුරට යන්න යන්න මේ power එක අඩු වෙන්න පුළුවන්. එතකොට ඒ energy එකක් නැහැ. ඒ හින්දා එතනින් එහාට ඒක propagate වෙන්නේ නැහැ. අඩු වෙවි ගිහින්. So if I generate high power or high energy, I'm high and if I'm shouting, right? So then it may go further than the previous case, right? So likewise, so these concepts are there: the energy or power, and then power or sound intensity level. Right, so that's the physical thing. Again, that's a physical thing, huh? Right? However, when it comes to ear, right? If there's a person here, right? He is not sensitive to this intensity or the power, right? But this person is sensitive to pressure change, pressure. ඒ කියන්නේ දැන් sound එක මෙහෙම මේ power එක තියෙන energy එක තමයි propagate වෙන්නේ. හරි. එතකොට හැබැයි දැන් physically energy වුණාට නැත්නම් power power එක වුණාට, so physically it is power, but we are not sensitive to the power. We are sensitive to the pressure change, right? Pressure එක change වෙන එකට තමයි අපි sensitive. So actually intensity, power, sound intensity and sound pressure, so these are, I mean, related, right? So however, for us as human, when we are hearing, pressure level is more important, right? So we talked about sound pressure level. Pressure level, sound pressure level. So based on sound pressure level, we can identify the loudness of the sound, right? Sound pressure level or acoustic pressure level is the logarithmic measure of the effective pressure of sound relative to a reference value, right? So this sound pressure level, so we are sensitive to sound pressure, but our ear, it is kind of really so it identifies this sound pressure level in a weird manner, right? If sound pressure goes like from one level to another level, like 10 levels, right? මේ sound pressure එක මේකෙදි එකයි නම් ඒක 10 ගුණයක් වැඩි වෙද්දී අපට මෙන්න මේ 10 ගුණය කියන එක මේ විදිහට පේන්නේ නැහැ. මේ අපිට දැනෙන්නේ නැහැ. අපිට ඇහෙන්නේ නැහැ. ඒක අපේ යන්නේ logarithmic විදියට. So in our ears, they identify these sound pressure levels in a logarithmic scale. Okay. So in that case, so any sound, any pressure, so we have a standard for a pressure levels, right? So, so for example, so we have loud sounds, and then so usually the sounds that we cannot hear clearly, right? Like faint sound, loud, faint, right? So for example, can you hear your breathing? Now, no. The thing is, like, so when you are hearing now, so when you are hearing, so what is the lowest level that you can hear? So sound pressure level, usually we measure in Pascal. Pascal, we consider micropascal, 20 micropascal, 20 micropascal, Pascal, this one, or this is 20 micropascal. So usually we consider this is the lowest level that we can hear. Actually, in a general case, generally, so when you are in a quiet room, right? Very, very quiet place, right? Then actually you may not be able to hear that. You may not be able to hear that because the thing is, in our surrounding, so there's something called ambient sound. So that means even there's nothing, no sound, but still there are some very, very low sound. Generally, our air, right? So they have something called ambient sound. It has a level pressure, right? So because of those things, we cannot hear the lowest level in most of the cases. But if you can go into a room where the sounds are like, for example, soundproof, and then we remove some for example, so there are some rooms. I don't remember the name. So they are called anechoic chambers or something, right? Like in those rooms, I've been to such a chamber once. So there are no reflections of sound, right? And then those are soundproofs from outside. So outside sounds cannot be entered, right? So those rooms, and then actually in this room, the structure is created in a way that no reflections of sounds, right? Again, බිත්තිවල ඇදිලා පරාවර්තනය වෙන්න බැරි වෙන්න මේක හදලා තියෙනවා. ඊට පස්සේ for example, So let me check so whether I can show you. Yeah. So there are some. Right, so these anechoic chambers, right? So it is something like this, no reflections of sound. And then even like the place that I've been to, so there was no flow, right? It is like යකඩ දැලක් වගේ තියෙන. ඒ දැල උඩ තමයි අපි ඇවිදින්න ඕනේ. ඒතකොට ඒ බිමින් අර රිෆ්ලෙක්ට් වෙන ඒවත් නැති කරලා තියෙනවා. So something like this here. Yeah. So here in such room, I mean, when I was there, it is really, really creepy, right? Like very, I feel kind of I am in a horror movie or something. Like no reflections, no soundproof, so no outside sounds. So then I have heard that like in a very if you spend in such room, so then you can hear your heartbeat. I didn't, because I was with some other people, so we were shouting, right? Like then the sound is like I mean it is the sound is kind of very empty, right? So we are used to listen to these reflections of these sounds, and then so that's how we feel it. But without those things, it is like බොල් හඬක් කියලා කියන්නේ අන්න ඒ වගේ එකක් තමයි මේ වගේ. I don't know whether so they are in Sri Lanka, right? Anechoic chambers, right? So somehow so this is the sound actually Pascal sound intensity. This has to be sound pressure, sound pressure. As I told you, sometimes we use them interchange, but it is sound pressure. This is the lowest that we can hear, right? So based on this, we identify the sound levels of other sounds. Yeah, do make අපිට ඇහෙන ඒක බේස් කරගෙන අපි අනිත් ඒවා මොන ලෙවල් එකේද කියලා හඳුර ගන්න. Right? So this is the P0 means this value. So any sound, the pressure, if we give the sound pressure, so then we can find the sound pressure level, right? So we use like 20 here, right? To make it, right, like for example, if this is 0, the loudest, right, threshold of pain, the loudest that we can bear, right, it would be 140, right? So we can find a really nice set of levels here, right? Because we are using like 220. It's basically right. So this is sound pressure level. So this is called decibel, right? Decibel. Decibel කියලා කියන්නේ මේ මේකෙන් එහෙම ගන්න level එක. Sound level එක. Right. So then loudness. Loudness is the subjective perception of sound pressure. So that's how we identify, or that's how our perception of the sound pressure. That attributes of auditory sensation in terms of which sounds can be ordered on a scale extending from quiet to loud. Quiet sound, loud sound, we identify. It is a psychological measurement of the magnitude of sound, which includes everything from its frequency, pressure, harmonics, surface, other things. The loudness of sound is not the same as the amplitude of sound. Amplitude and loudness are related, but not the same. Right? Amplitude is, as I told you, the physical perspective, but then, so based on that, we can perceive the loudness. Okay. So here, different frequencies. So based on the frequencies, the sound level that we hear could be different. So based on, so this is how it is changing. And then pace. This is another aspect of sound. Pace is the time difference between two waveforms in relation to a corresponding point in wave cycle. Right? The pace is for example, like molecules are, so air molecules are vibrating this way up to this place and then go back here and then here and then come back to the original neutral position, right? So this is oscillation movement, right, of sound or any wave. We can identify this this kind of movement. The pace is where this molecule is at a given time. So for example, now this one is here and then one point it is here and it comes here. Likewise, කොහෙද මේ මොලිකියුල් එක තියෙන්නේ කියන එක වගේ අයිඩියා එකක් තමයි මෙතන තියෙන්නේ, right? So if we take similar, right? Right, it is here. Sometimes it is similar to this one, this position. So we are identifying this pace using circle, right? So if I start from here, for example, right? This is 0, right? Then it goes up to this. So then it is 90 degrees. And then half, it would be 180 degrees. So likewise, the pace is measured in degrees. So then here 270, and then when it comes back to here, so then it will be 360 again. So that means one circle of this one movement, one vibration. One circle of vibration is considered as 360. So based on that, we can identify the position. Right? කොච්චර ගිහිල්ලාද? දැන් මෙතෙන්ට ආව නම් ඒක මට 30 වෙන්න පුළුවන්. 30 degrees. It could be 30 degrees. And then when it comes to here, it is 90 degrees. When it is on the way to the other side, when it is here, it is 180 degrees likewise. So this is the pace, right? So pace is important, really, really important, right? When we combine waves. So that's where it is important, right? Pace is the time difference between two waveforms in relation to corresponding point of the waves. වෙලාවේදී waveform එක කොතනද තියෙන්නේ, right? For example, suppose if we have these two waveforms, right? This waveform start here, at the same time the other waveform starts like this. So we can say they are in the same pace. Then if we combine these two waveforms, like for example, we can generate this kind of wave. If these waveforms are different in 180, so then in that case, the combined waveform would be something like this. No wave. We can cancel each other, right? So in physics, definitely you may have learned these things, right? Like, so in, okay, so on this molecule, so I am generating two waves from here and from here, right? So then suppose from this wave, right, this one is moving upwards. So at the same time, if this waveform, this wave tries to move it the other way. කියන්නේ එකම වෙලාවෙදී මේ මොලිකියුල් එකට දැන් වේව්ස් දෙකක් ඇවිල්ලා ඒ දෙක දැන් ඔන්න මේ මොලිකියුල් එකට වැඩ කරනවා. ඒ මොලිකියුල් එකට මේ ඇටැක් කරනවා කියලා හිතන්න. එතකොට මේ එක වේව් ෆෝම් එකකින් මේ පැත්තට ඇද්දොත් අනිත් වේව් ෆෝම් එකෙන් අදින්නේ අනිත් පැත්තට නම් මෙයා එතකොට මෙයා මේ මූව් වෙන්නේ නැහැ. මෙයා මූව් වෙන්නේ නැහැ. මෙයා මෙහෙමම ඉන්නේ. මේ පැත්තට. In this case, if they are 180 degrees different, this waveform and this wave, so this wave and this wave, the difference is like this. So then this molecule won't be moving. It'll cancel this. එහෙමයි අර cancel වෙනවා කියලා කියන්නේ. ඒතර එතනින් පස්සේ ඔක්කොම තියෙන ඒවා ඔක්කොම එහෙම cancel වෙනවා. So that's why it is cancelling. But in this case, right, like two waveforms, this waveform, in the other case, this waveform tries to move this molecule towards up. The other sound wave, it is also trying the same. මෙයාගෙන් force එකක් එනවා මේ පැත්තට යන්න, මෙයාගෙන් force එකක් එනවා මේ පැත්තට යන්න. මේක මේ විදිහට අඳින්න නැතුව අපි අඳිමු මෙහෙම. මෙහෙම මෙහෙමත් වෙනවා මෙහෙම. මේ දෙන්නම මේකෙත් එහෙමද? So එන්න එනර්ජි එක මේ පැත්තෙන් ඇවිල්ලා මේ දෙන්න දෙපැත්තට අදින්න. දැන් මේකෙදි this one and this one both are trying to move in this molecule towards up. In that case, this one has like maybe එකෙන් 10කින් එයා පව එක දෙනවා නම් මේ අනිත් එක්කනත් 10කින් දෙනවා. ඒතකොට මෙයා 20ක පව එකකින් ඒතකොට අර මේ එක වේව් ෆෝම් එකකින් තිබුණාට වඩා වැඩි ඇම්ප්ලිටියුඩ් එකක් එයාට තියෙනවා. Right? So in a pace, so this is how the pace is important, right? So you have to be careful when there are two multiple sound sources. There are multiple sound sources, so you have to be careful. Sometimes based on their pace, the effect that we are expecting won't be there. අපි බලාපොරොත්තු වෙන මේ multiple මේ sources වලින් මෙන්න මෙහෙම වෙයි කියලා. හැබැයි අරිසියට මේ pace එක වැඩ කරලා මේවා මේ නිකන් පොඩ්ඩක් අපි හිතන විදිහට නොවෙන්න පුළුවන්. So if they are like different waves, if there are different waves, new wave would be created like this. يعني මේ එකම wave එක නයි එකම විදිහේ wave එක නයි කියන්නේ. ඒ කියන්නේ මේ wave එකේ තියෙන ලක්ෂණයි මේකේ තියෙන ලක්ෂණයි දෙකම සමානයි. මේ wave එකේ තියෙන ලක්ෂණයි මේ wave එකේ තියෙන ලක්ෂණයි දෙකම සමානයි, pace එක වෙනස්. දැන් මේකේ නම් pace එකත් එකයි. So they are in the same pace. All the other aspects are the same. In this case, different pace, all the other aspects of these waves are the same. In that case, it will be like this. But in most of the cases, so we may have different waves, right? The aspects of these waves would be different. And then again, with the pace, the result would be different wave, combined wave. Right. Pace. And then harmonics. Right. So this is another concept. Harmonics are a series of related frequencies that make up a sound. Harmonic, so I will read this first and then I will explain. A harmonic is a wave with a frequency that is positive integer multiple of the frequency of the original wave, known as the fundamental frequency. Right? So harmonics are, so suppose we have a sound or tone, sometimes we call it a tone, right? So we have a sound. Right? Suppose the frequency of this one is 440 Hertz. right? Then suppose we are playing C note in a keyboard. C note, we call middle C, right? So usually, like in a standard manner, the frequency of this note is 440, right? So this is called the fundamental frequency, right? Fundamental frequency. However, when we take, if you record, so first you find a keyboard and you play middle C note, right? Then what you are expecting is, you are expecting a sound wave, right? Right, like 440 hertz. Right? Then but actually you are not getting this kind of wave, this kind of pure wave. Pure wave එකක් නෙවෙයි එන්නේ. ඇත්තටම it would be a combination of other frequencies as well. It would be a combination of this frequency. This would be the dominating frequency. This would be the dominating. However, so because of when sound is generating, so there are a lot of things happening, right? Like, so they are reflecting and then they are combining different frequencies, and then it would be generated. Right? So usually when we take the real, so we don't get pure wave, so we will get a combination of this frequency, and that frequency is harmonics. So that means 440 would be there, and also it would be the double, 880 would be there, hertz. Then multiples of this, right? Right. So for example, in this case, 200, right? 200. So then the second harmonic, we call this one the first harmonic. Again, අපි 200 hertz 200 note එකක් නම් අපි ඔබන්නේ. හරි? එතකොට ඒකේ තියෙනවා මෙන්න මේක අනිවාර්යයෙන්ම තියෙනවා. Right? This is the fundamental frequency, but then not so dominating, but still these frequencies would be generated as well. So මේ 400 ඒවත් generate වෙනවා. ඊට පස්සේ 600 ඒවත් generate වෙනවා. 200 දෙගුණේ තුන්ගුණේ, right? 200 දෙගුණේ තුන්ගුණේ හතරගුණේ පස්ගුණේ, එන්න මේ විදිහට harmonic generate වෙනවා. So the sound wave that we are getting would be a combination of a composite waveform like this. In this case, there would be this, and then right? twice this one, and then 3 times, and then so on, like. Again, 400 තමයි dominate. 440, right? So this would be dominate, right? ගොඩක් ඒකේ මේ generate වෙන්නේ මේවා. හැබැයි ඊට ටිකක් ඊට අඩුවෙන් ඊට සෑහෙන අඩුවෙන් මේ 880 මේ frequency තියෙන මේ waves generate වෙනවා. ඊට තවත් අඩුවෙන් මේ 3 ගුණයක් වෙන මෙන්න මේ එකේ ඒවා generate වෙනවා. ඊට පස්සේ ඊට තවත් අඩුවෙන් ඒකේ ඊළඟ harmonic එකේ ඒවා generate වෙනවා. Right? So these are called harmonics. එතකොට අපි මේ C note එක ගහලා බලාපොරොත්තු වෙන මේ වගේ pure sound එකක් වුණාට ඇත්තට මේක pure sound එකක් නෙවෙයි මේ වගේ combination එකක්. Right? එතකොට ඒක මෙන්න මේ වගේ එකක් වෙන්න. Combination of different frequencies. Harmonic is a wave with a frequency that is positive integer multiple of the frequency of the original wave, known as the fundamental frequency. The original wave is also called the harmonic, the first harmonic. The following harmonics are known as the higher harmonics. First harmonic, and the second harmonic, and the third harmonic, and so on. Sometimes we call this is a fundamental frequency, first overtone, second overtone, and like overtones, or harmonics, overtones, or harmonics. Same idea, right? All sounds we hear are combination of sine waves at different frequencies and amplitudes. Different frequencies and amplitudes. Right? Harmonics. So you can ask any questions, right? While we are discussing here. Right? So then, so this is actually something related to music, right? But I'm going to talk about that here, right? Timbre, right? Timbre. So it is the quality of auditory sensation. So, for example, if you hear the sound of a violin which plays the same note, right? For example, C, right? C note. Sa කියලා ගහනවා කියලා හිතමු මේ violin එක. Same note, right? Right. From violin, the same note, C note, right? And then using a keyboard, we play the same note. Piano, right? For example, piano. We play the same note, right? C. The frequencies are the same. Suppose their amplitude or the loudness could be the same, right? But still, a person can hear the difference. So he knows that is violin. And then he knows this is piano. The quality of sound is different. Even other things that we talked about earlier, like the pace and then loudness, amplitude, frequency, all same, but still we can identify difference. The reason is their waveforms are different. The main reason is like when in a flute, this sound is generated using the vibrating air, right? But in violin, the sound is generated mainly on using that strings, vibrating strings, right? So because of that, even though they are playing the same frequency, same loudness, everything, but the sound form would be different. ඒ කියන්නේ දැන් එක ඉන්ස්ට්‍රුමන්ට් එකේදී සවුන්ඩ් එක ජෙනරේට් වෙද්දී ඒක සවුන්ඩ් එක තැන් වල ගිහලා රිෆ්ලෙක්ට් වෙලා ඒක මේ එන විදිය වෙනස්. එතකොට ඒකෙන් ජෙනරේට් වෙන මේ සවුන්ඩ් වේව් ෆෝම් එක වෙනස්. ඒක frequency දෙක සමාන වෙන්න පුළුවන්. Frequency would be the same, but the waveform would be different. So timbre is that, right? Like so based on the waveform, so we can identify the quality of the sound. So, for example, the number of overtones, number of harmonics in this one and this one would be different. Can harmonics කීයක් අර එකතු වෙනවද කියලා මම කියවනේ. කම්බයින් වෙනවා. අන්නේ කම්බයින් වෙන ඒවා වෙනස් වෙන්න පුළුවන්. කම්බයින් වෙන ප්‍රමාණ වෙනස් වෙන්න පුළුවන්. Right? Based on how that sound is generated. Timbre is the waveform. Right, okay. So basically, like we talked about several aspects of physical and then some of loudness and then timbre, right? Some psychological aspects, right? So somehow, so these are basically the aspects of sound, right? Then, so these are the things that we should know on the psychological aspects, right? Like physiological. Right? Like these are the parts of the auditory system. So we have our outer ear and then ear canal, right? And then the eardrum. Eardrum vibrates, right? So based on that, so we have three parts here. Malleus, incus, stapes, right? So these parts would be vibrating, right? The vibrations of eardrum would be transformed into the inner ear using these three parts. Right? They're very sensitive. Right? Then, so based on the vibration of those, so we have something called this snail-like thing, cochlea, right? So these vibrations are transmitted into cochlea, right? So this cochlea, so it is something like this, right? So this is the base of the cochlea, and then this is the top or apex. We call it apex, right? So this organ is sensitive to frequencies. Like different parts of this cochlea is sensitive to different frequencies. So that's how we identify different frequencies. That's how we identify the pitch. And frequency can pitch check and pitch check identify. Right? For example, bass is sensitive to high frequencies. Right? The apex is it is sensitive to low frequencies. Right? So 20 hertz frequency would be there. Right? So based on the vibration of these, so it will identify the proper frequency. Only that area would be vibrating or ripple, right? So based on that, it will give that electrical signal. It will generate electrical signal to auditory nerve. Then it will be taken into the brain, and the brain would identify, okay, so this sound is low or high. So based on the sensitivity of cochlea. So මේකේ කොයි තැනද vibrate වෙන්නේ කියන එක අනුව අපිට අඳුර ගන්න පුළුවන් මේක high pitch එකක්ද low pitch එකක්ද කොහොමද. Inside that, inside cochlea, so there's a special organ called basilar membrane, right? So basilar membrane, it is inside, it is here. රතු පාටට වගේ තියෙන්නේ මැදි අන්න ඒක basilar membrane, right? basilar membrane එක තමයි මේ දැන් අර high frequency එකක් වුණොත් ඒකේ මේ base එක තමයි sensitive වෙන්නේ. Low frequency එකක් වුණොත් එහෙම apex එක තමයි sensitive. Right? Right? So these are some differences between different species. Like human, so we have the auditory like 20 to 20,000 basically, right? Then frequencies more than our auditory range are called ultrasound. And then like in the right side, the left side, so we have infrasound. So elephants can hear them. Elephants are sensitive to low sounds as well. So dogs are sensitive to our range as well, to ultrasounds. So dolphins, their range is very big. Right? Bats, dolphins, right? And then sound transmission. So I will explain these parts I'll go through very quickly, right? So when the sound is transmitted, so we can identify several concepts there. For example, isolation. So isolation is cutting down sound from leaking into or out of room, right? From inside to outside or from outside to inside, isolation. Right? The simplest way to cut down sound is put a solid wall in its way. The more solid, the better isolation you'll get. And cutting down. Sound cut down කරන්න පුළුවන් කොහොමද? හොඳම විදිය solid එකක් තියලා. So then reflections. I told you in any most of the sounds we hear, they have reflections. So that's why in most of the cases we have harmonics. We cannot generate, in special cases we can generate pure sounds, but usually sounds are reflecting. So always there are overtones and a mix of multiple frequencies. Sound reflects, bounces, absorbs of a surface. Bounce, right? So usually it bounces with different surfaces, right? So when we hear the direct sound as well, the reflections, echoes, and revibrations. So revibrations are echoes that are so close together. Right? Reverberations. So we are going to learn these concepts when we are working in the sound, right? Multiple echoes වගේ තියෙනවා නිකන් එක දිගට echoes ඇහෙනවා වගේ. Reverb, right? So then refraction. Sound wave refracts when it passes from one medium to another. හැරිලා යන එක. Right? When a sound signal passes from a thinner medium to a thicker or denser one, it refracts away from the surface or the denser medium. Right? Refraction. Diffraction. Diffraction is the bending of waves as it either passes through a barrier or passes through an opening. If sound is passing, right, in an opening like this, then this part would hear that sound is generated from this place. يعني මේ මෙතනින් generate වෙනවා වගේ තමයි sound එක මේ පැත්තේ ඉන්න කාට හරි ඇහෙන්නේ. ඒක generate උනේ එහා පැත්තෙන් ඇවිල්ලා මේ මෙතනින් මෙන්න මේ විදිහට යනවා. If it is a broad slit, broad opening, so then there won't be a much difference, right? And then so we have, there are two openings, then the sound effect would be totally different. diffraction, right? Okay. Then absorption. Absorption consumes the energy of sound. Sound does not absorb equally for all frequencies. Right. Right. This is a mistake. Huh? This is so these when these are copied. So I don't know. Yeah, this is so sound is absorbed like all the time. Right? So energy is consumed. Right? By the medium and other objects. So interference. Interference is the addition of two or more waves resulting in a new wave pattern. Right? So basically this is like combining two waves, right? So based on the wave forms, right? Interference, right? Right. So that is the end of this set of slides. Right? So any questions on this one? So there are many other things that like when we talk about sound, we can talk, I mean, it is just, it could be just one module, like sound and audio. So there are modules like that, sound and audio. But we can talk about sound waves. So now we have talked about that for 2 weeks, right? So then, so from here, we are going to talk those things with some like from next week, we are going to start the practicals. Today, we may not have time to do that, but next week, we are going to do practicals. We are going to start producing some, could be music or any audio, right? Right. So actually, we can have another 10 or 15 minutes. So I can start. So I'm going to share the lecture 2, so you can go through that. So today I'm going to share that, and then I will just give a brief introduction to that. So most of the concepts we have already talked, right? So we talked about those things, but I want to give you very briefing into that. Right? Okay, so lecture 2. So here we are going to talk about fundamentals of sound and music, right? So with the musical sounds. So musical sounds, all are vibrations, right? Sounds are vibrations. But musical sounds, they are vibrations which are strongly regular. So that's why we like to hear them, right? So it doesn't have to be any notes played, notes playing in a instrument. It doesn't have to be that. It could be like a regular vibration sounds. So sometimes when some person is talking, like should it would be very pleasing, right? Maybe not like me, but some other people who are, they have people with really nice, beautiful voice, and then they talk in a nice manner. So then it could be, it doesn't have to be just musical tones or notes played in an instrument or singing. It doesn't have to be that. It could be any vibration which are strongly regular. It would be very difficult to find 100% regular, but mostly regular, right? For example, this could be regular. This is not regular. This is irregular. See? Right. When you hear a regular vibration, your ear detects the frequency and you perceive this as a pitch of a musical tone. Our basilar membrane or the cochlea, right? Basically, the basilar membrane is the detector of the frequencies. So basilar membrane detects frequency, right? Frequency එකක් detect කරනවා. ඒ frequency එකක් detect කරාම මේ regular ගතිය දැනෙනවා. ඒ pitch එක දැනෙනවා. හරි. ඒතර දැන් අර මේ out of pitch කියලා කියන්නේ දැන් මේ ඒ අර regular එක දැනුන්නේ නැත්නම් ඒ pitch එක දැනුන්නේ නැත්නම් තමයි මේ අපිට නිකන් අර ඒක musical නෙවෙයි නිකන් එයා අර කියන්න ඕනේ note එක නෙවෙයි වෙන එකක් කිව්වා වගේ අපිට දැනෙන්නේ. ඒකයි. Right? Non-musical sounds are complex mix of different and changing frequencies. Our ear still follows these vibrations, but there is no strong regularity from which you can pick up a musical tone. Right? So musical tone. There are some frequencies that are pleasing or that are regular, that provide some regular vibrations in our basilar membrane. So that's why we identify them as musical sounds. Right? So in so there's a concept called consonance and dissonance. Consonance means pleasing, and dissonance means the opposite of that. There are some musical notes they are very pleasing, and there are some notes, even musical notes, and some other like non-musical notes, they are not pleasing. So it is called dissonance. Consonance means like pleasing. So there are several theories for this consonance and dissonance. So those are just for the just to have an idea. So one is Pythagoras. Pythagoras is the first one who gave this idea, consonance and dissonance. Why some sounds are pleasing and why some sounds are not pleasing. So his idea was because of the ratios of two tones. The ratio, the frequency ratio, right? So F1 and F2, right? If their frequency ratio is, so this one, the frequency ratio is, if they are simple numbers, like 2, 3, 4, 5, right? Then the interval is more consonants, more pleasing than if those are bigger numbers. For instance, the perfect fifth, don't worry about the perfect fifth now, has approximate ratio is 2, 3. So මේකෙදී කියන්නේ sounds දෙකක් එකට ඇහෙද්දී ඒ දෙකේ frequencies අතර මෙන්න මේ වගේ ratio එකක් තියෙනවා නම් ඒක හොඳ හඬක්. ඒ කියන්නේ ඒක අපිට ආස හිතෙනවා pleasing කියලා මේ කියනවා. ඊට පස්සේ in tritone, don't worry about that. In that case, their frequencies are in this ratio. So that means, so those are not simple numbers. These are kind of bigger numbers. So this ratio gives pleasing sound than this. Even in music, so some tones are more pleasing than others. So this is the reason, as Pythagoras explained. But then actually that idea has now changed. So this person Helmholtz, right? So he's a German. He's a German philosopher and scientist, actually. Introduced the theory of beating harmonics, which determines the consonants of pair of simultaneous complex tones based on strengths and the numbers of beating harmonics. So in any sound wave, so there are fundamental frequency and then harmonics, right? Harmonics of the fundamental frequency, right? If they have beating harmonics, right, then there could be some dissonance can be occurred. Right? He ordered the consonances of two-tone intervals, and this model is considered a scientific basis of consonance in Western music. Right? This idea is in Western music, basically. So this is the dissonance is also called roughness of music. So maybe Akalanka may know, like sometimes we use this roughness or this unpleasantness creative, right? So for example, especially in folk music, right? Like folk music, we use some rough sound. I don't like to say rough sounds, but that concept is used. කියන්නේ අර pleasant නැති sound පාවිච්චි කරනවා creatively. even in Sri Lankan folk singing, right? They use that. I mean, it is just my opinion. Those are not, there are no research as I know, right? But there could be some research which are not aware to me, but those are there, right? In different styles of music, dissonance, consonance, these concepts are used. For example, early music like ගත්තොත් එහෙම baroque music කියලා කියන්නේ මේ ශතවර්ෂ කීපයකට කලින් ඒවා නිකන් අර පල්ලිය බේස් කරගෙන හැදිච්ච මියුසික්. ඒ කියන්නේ මේ කතෝලික පල්ලිය මූලික කරගෙන මේ යුරෝපේ හැදිච්ච මියුසික්. ඒතර ඒ වගේදී අර මේ in those music they consider like pleasing tones, pleasing sounds are so when we are creating music, they should be pleasing. So we are getting closer to God or divine power. So because of that, we have to use pleasing sounds. So we have to we don't so other like unpleasant sounds should not be used. So that's the idea they had at that time. Then it changed a lot, right? So then in last century, like jazz music came, and then with some African influence like blues. I'm talking about I'm talking about Western music because that's one system, right? And then the same idea was there in Indian music, right? So like some sounds like, so they are divine, right? So then we shouldn't combine these sounds. So there are some things, but then later people did some like experiments. For example, like heavy metal, when it comes to heavy metal music, so they used like devil's notes, right? Yakshayage tones පාවිච්චි කරා කියලා තමයි දැන් ඒ කියන්නේ එහෙම පාවිච්චි කරලා තමයි heavy metal music නැත්නම් rock music එහෙම පටන් ගත්තේ. ඒ කියන්නේ කලින් පාවිච්චි නොකරපු මේ combinations එකටි පාවිච්චි කරනවා. So now we are using, now modern experimental music, so they are using all sort of like consonants and dissonance sounds. So if we take like modern experimental music, I don't remember names, but I can give sometime. Like if you listen, sometimes you feel, is it music? Are these music? Sometimes we feel like, can music the නැද්ද කියන level එකටම ඒවා experiments කරනවා. So Akalanka, actually you are doing experiments as I have seen, right? So you can think about these things like so what is musical? It is a question, it's a big question actually. Sometimes now for example in Sri Lanka, like the one person I know is Ajit Kumar. So he's a underground musician. So I've been to his shows some time ago. Like so he's using roughness, so dissonance, very creative, right? Definitely Akalanka may have better idea and better knowledge in this case. So yeah, so when we are doing some practicals and when we are creating audio, right? So we can talk these things more, right? Okay, so that's one idea here, and then I'm not going to take much. So here, pitch classes, notes, those are explained, and then melody and harmony, right? And then duration, timing, right? And then again, timbre, right? So it is, so these are musical terms. In musical terms, I am explaining these things. Timbre, it is the same actually. And then, yeah. Then there are many things to add here, but still, like we can start with those things, right? So those ideas, and then we can go for our main part, like audio production. So in that case, DAW or digital audio workstations can be used, right? So these are electronic devices or applications of used for recording, editing, and producing audio files. We can record, then we can edit, right? And then finally we can produce music. So record and edit, we can mix and we can alternate, right? We can change some aspects, and then we can produce an audio file, right? So I'm going to talk these things very, next week I'm going to talk briefly these things, and then we are going to go to the next part. So here, there are many software that you can find. Akalanka, any DAW software you're using?
I'm using Cubase, Logic Pro, and Pro Tools.
Okay, so Pro Tools, it is like the industrial standard, but so I have given a list here. So there are many other, but these are kind of, I picked them as based on my preference, right? And recommendations, of course. So Pro Tools, it is considered as an industry standard, and then Cubase, and then so most of these in the first slide are not free, but some of them they provide some versions that we can work with. And then in the second slide, so these are some free, some are open source software, right? But here the GarageBand, it comes with Mac OS. So if anyone is using Mac, so you may have this in your computer. Which software is the best? So that's totally up to you, right? Because I mean, for example, as a professional like Akalanka, so he may have his choices because he's producing music for the industry. But at this level, so we can start with any, right? And then, so for as a beginning, you can use one software that I started with is Audacity, right? Like Audacity is, we can record very, very simple music, and then we can do some editing, and we can create sound files. But these audio workstations, they provide many features that we can that providing the flexibility to do editing and mixing. So what I want you to do is you should so this week the homework would be right. So you can go with, for example, you can check Cubase, right? And then I'll provide some links to in on LMS, and then Cakewalk or LMS, right? And then just download. For example, these are free, totally free. These, and then like the Waveform Pro. So in this case, it is like the older versions are free. When the new version is arrived, so older version can be taken. And the other thing is, even these are, for example, like Cubase, right? So you can, I mean, officially I cannot recommend like pirate copies, but those are available, right? So there are different versions, right? In Cubase, like Pro, Artist, like Elements, right? So different versions are there, right? So there are many other, right? But just try to search and then try to download one and check how it works, right? So that's the that's your homework for this week, right? So then next week, so we can talk about your experience on those, right? If you have time, you can check all these, but I mean, it would be waste of like time and resources. But you can choose several and check how they go. The best DAO is it is what you are comfortable with. If you can work with that, and if you can achieve what you want to do with them, so then that's fine. But at this level, the main problem that we are having is like some are not free, so we have to buy them. Right? So with that, so you can try these without, I mean, it's mainly these, right? So those are free. You can find free versions. Right. So any questions? So I'm going to stop at this point. So next week, I'm going to briefly explain what I skipped like this, and then I will go to the next, like audio, introduction to audio and audio production. Right. So, any questions? Right. So then we can conclude the session. So thank you for joining. Next Monday, yeah. So next Monday, definitely I'll start at 1, right? I'll start at 1. Don't forget the homework, huh? Because from next week, for our practicals, we may need. Right. Okay. So thank you, and see you next week. And don't forget the events of the conference. Huh? Okay. Stay safe. Good night.